Good morning. I think that's what I say at the beginning of everyone. It's probably kind of annoying. But anyway, triangle similarity works the same way or similarly as triangle congruence. Just a little review. Similar triangles are the same shape, but different sizes. And to be a little bit more specific, they have congruent angles, and then I'm going to put in parentheses corresponding, because I mean the ones that are in the same location are congruent, not all the angles. Congruent angles and proportional sides. So as soon as you see in any problem that you're talking about the sides of similar triangles, you should basically draw a little proportion. That's going to work more with the algebra stuff, but it also comes in handy here. If you relate this word similarity or similar with this symbol, it's going to help you times a zillion. So in congruent triangles and proving them congruent, we end up with 5 different ways we can prove them congruent. For similar triangles, we end up with 2 or 3. 2 angles, angle, angle, and you do need the squiggle for similar. Side, 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 similar, or side, angle, side, similar. All right, and so I'm going to show you how that works down here. So if we're looking at angle, angle, all we need are 2 corresponding angles that are congruent. So if we look at number 1, we have this angle 75 is congruent to that angle. That's one set of corresponding congruent sides. And then, or congruent angles. And then we have 2 more angles. But we don't know if they match yet. So we're going to use the triangle angle sum theorem, which just says that the angles in a triangle add up to 180 degrees. So I'm going to do this little work here just in case anybody needs to see. But you're going to add together 2 angles, 74 plus 75, which equals 149. And then subtract from 180. And that equals 31 degrees. Well, luckily, we know that this corresponding angle in the other triangle is 31 degrees. If we added 75 plus 31 and subtracted from 180, we'd also get 74, but we don't need to check all 3 angles. As soon as we find 2 corresponding congruent angles, then we know that yes, these are similar by angle, angle similarity. All right, so sometimes you're going to have to use the triangle angle sum. Sometimes you're going to have to use relationships with parallel lines or vertical angles or what they tell you. So in this one, we have the pair that they gave us. This is given. And if you're looking for another set of congruent angles, a lot of people will say W and Z because they almost look like right angles. But since they are not marked congruent and we have no words anywhere else to give us more information, we can't count these as congruent angles. But we can mark those because what kind of angles are those? Vertical, and vertical angles are always congruent. Now we have 2 corresponding pairs of congruent angles. So yes, these are congruent by angle, angle similarity. All right, let's show some examples of side, side, side similarity. In side, 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 you want to make sure that you have all 3 sets of corresponding sides that are proportional. So you should draw the proportion bars kind of for the ratios of the sides, and we're going to compare them and see if they're equal. The easiest way to match these up is to look at each triangle, and I'm just going to go with the small side of this triangle matching with the small side of that triangle. So 3 over 6. You could do 6 over 3, but then you need to use it the same way for the next one. Then we have the medium side of this one and the medium side of that one. And I'm not telling by looking at it, I'm looking at the numbers. 4 and 8 are the middle numbers in those triangles. And then we have the longer side of this one with the longer side of that one. So 5 over 10. All right. We need to simplify these fractions or turn them into decimals to compare them. I can tell just off the bat that these are all 1/2, but I'm just going to go with fraction or decimal form because that works really easily in a lot of ways. So these are all the same. Each of these equals 0.5. Since that's true, then yes, these are similar by side, side, side similarity. okay, because the sides are proportional. For the next one, we're going to do the same thing. I'm going to highlight the small sides, the middle side, and the long side of each triangle. And then we're going to set up the three ratios and see if they are proportional. So we're going to put small with, or these two, the small side of one with the small side of the other. I did the big triangle first and the small one second, so I need to do that for every single one. 32 over 25 and 35 over 28. I'm going to type these in my calculator and see what they come out to. This is 1.25. This is 1.28, and that should set off an alarm bell, but I'm just going to finish it. And this is 1.25. Since these three do not match, then no, these are not similar. Does that make sense? I hope that makes sense. All right, and then we're going to go with side angle side. Side angle side you do very much like this, except for we only really have to compare two sides because we have the angle between them that's fixed. All right, so we're going to do the small side of the first triangle with the small side of the second one. Those are corresponding. The longer side with the longer side. And we're going to check the ratios and see if they are congruent. So we have 8 over 6 and 20 over 15. Be careful that you don't do 8 over 6 and then 15 over 20. That wouldn't be proportional. You need to go big to small, or small to big, small to big. All right, let's check those. 8 divided by 6 is 1.3 repeating. 20 divided by 15 is 1.3 repeating. Since they are exactly the same, then yes, these are similar by side angle side similarity. All right, and last one. Hopefully you can see two triangles in this picture, but here's one, the small one, and then we have this one, the whole triangle that's bigger. This trapezoid right there, we're not really going to be messing with that. That quadrilateral, I guess, is more specific. All right, now since we're in the side angle side section, it should kind of go without saying that somewhere in here there's an angle that's congruent to the same angle in another one. And that's actually right here. They both share this angle. It's part of both triangles, so that's our angle. So we need to compare the sides of these triangles. We have this side of the small one with this side of the long one. I just pulled that out to the side like a measurer, okay? And then we have this side of the small one with this side of the big one. So if we set up our proportions, or sorry, our ratios to check to see if they're proportional, we would have 12 over 21 and 15 over 25. And we want to see if those are congruent. This ends up being 0.571 something, and 15 over 25 is 0.6. Since these are not identical, then no, these two triangles are not similar. All right, I hope that gave you a good general overview. I'm going to stop this video and do a second video that goes over a couple more examples. And then that's it.